Hey guys, we're going to tackle a lecture a little differently today. Hopefully, this works a little bit better. Uh, Hopefully, you can see these guys here. I'll put them online too. Uh, we are looking at steps for the limit, and I don't know if this is just dirty or it's just going to be fuzzy for some reason. So, uh, if we look at this, so steps for our limits. The first thing when you deal with steps for limits is we are going to either plug in the x value. So this is where going to be the x value that the limit is approaching. Okay, let's see if that helps a little bit. The lights just went out, so there we go. If plugging in doesn't work, so if plugging in makes it undefined, then you go to step two. Step two. So you're going to go to step two. Step two is you factor it, then you plug it in. If you factor it and then plug it in and it gives you undefined, then you go to, well, this should be the two, then you go to step three. Okay? Then you go to step three. And if one doesn't work, two doesn't work, then you go to graph it. So then at the end, we're going to graph it. So let's just tackle graphs and the idea behind one-sided and two-sided limits. So if we look at this here, let's see how well this is going to work for us today. Let me focus again. If we focus in on this, let's make it a little bit larger here. And again, you guys can print these out so they're a little bit better. I'll have to see if I can focus this a little bit better. Okay, so this is actually as limit approaches x from the right. So it's just saying this means approaching from the right. Okay, so basically it is saying we're going to approach -2. Oops, this is negative. That's negative. The first one says we're going to approach -2 from the right. That's a little plus sign there. If we go to this graph, we go to -2 here. Here's -2. We're approaching from the right. So if we're approaching -2 from the right, which is the blue line, what's the y value becoming? Well, the y value is becoming 1, 2. So it's approaching 2. So as x approaches 2, f of x approaches 2. So my answer is 2. So this is going to be the limit as x approaches -2 from the right is equal to 2. Okay? So you guys kind of see how that works. So on this next one here, and I'll write these out a little bit better so you can see them. Let me try my pencil. Maybe a little bit better. So this one is asking from the left. So we're saying the limit, let me slide over a little bit here. The limit as, and this is number 2, the limit as x approaches -2 from the left. That's from the left. As it approaches it from the left, so I'm coming this way, we go to the red, -2 is right here. I'm approaching -2 from the left here, and my y value is approaching 3. So my answer will be 3. So it's all depending on how you approach left and right. So now if we look at this again, if we look at this next one, this is number 3 right here. So I'll do number 3 up here. I'll rewrite it because I can't really see on this. Number 3 is the limit as x approaches -2 from both sides. So if there's nothing there, it's going to approach both sides. So this is from both sides. So in your notes, it says, x approaches from both sides. So it's the red and the blue. So if I approach from the left and I approach from the right to -2, what happens? I actually approach 3 on this side and 2 on this side. So then we can't even make a guess for what happens in between. So this is going to be undefined. The limit is undefined. We don't know, or I shouldn't say undefined, I should call it does not exist. Okay? So when it doesn't converge on one point, it does not exist. So let's look at the green. If approaches from the right, 0 from the right, it's going to be 2. Approaching 0 from the right, it's going to be 2 because that's where it's going. If we're approaching 0 from the left, from the right, got it backwards. From the right, approaching from the right is going to be 0. Approaching from the left is going to be 2. And approaching both ways from here to here, since it doesn't converge on one point, it's going to be 0. So as you're reading these things, it has to converge on one point. And so you can pick a one-sided limit, which is coming from the right, or it's coming from the left, or a two-sided limit, which is there's no sign up here, and it has to converge on one point. So here we go. So let's look at our worksheet for today. So this is our worksheet for today. Let me back out a little bit. Our worksheet for today looks like this. Gives us our steps. Plug it in, factor, then plug it in, and then graph it. So I'll give you a couple examples, and then I'm going to let you guys kind of tackle it from there. So we went over how to deal with the graphing one. So let's just look at a real basic one here. Let's just look at the limit as x approaches 1 of x plus 1. So what we do, step 1, we plug it in. What do we plug in? We plug that in. So plug that in, we get 1 plus 1 equals 2. So therefore, the limit as x approaches 1 equals 2. So we plug it in. That's our first rule of thumb. It doesn't matter. Just plug them in. Plug them into your calculator and see if it gives you a value, you're good. If it makes it undefined, we're not. So let's look at another one here. Let's look at the limit as x approaches 4 of x minus 4 over x squared minus 16. So we look at that one. We need to learn how to factor that. So if I plug this in, I get 4 squared. 16 minus 16 gives me a 0 on the bottom, so it's undefined. So I can't use that. So step number 2 is going to be factoring it. So we get x minus 4 over x minus 4, x plus 4, plus 4 here, and then x minus 4, x plus 4. And so these will simplify out, and I'm left with 1 over x plus 4. So what does that do? Now I plug it in and I don't get an undefined answer, so then I can rewrite it as the limit as x approaches 4 is equal to 1 over 8. The limit as x approaches x minus 4 over x squared minus 16 equals 1 over 8. All right. So therefore, that's a little therefore sign. And that is actually there on the bottom. It's gotta love the glare. Nothing ever works exactly like you want it. So we've got a couple of different options when it comes to different things. So uh, if if it won't work when you plug it in, uh, and it won't work after you factor it and plug it in, just plug it into your calculator and look and read it and see how it approaches there. So that's the quick idea on limits, and we'll tackle some more in class today.